Good.
Is it good go time?
Yeah.
All right.
Hi,
Cool.
guys. How you guys doing?
Exciting 3 p.m. session here. Get the energy up. I left my rave music at home, but you can, play that in your mind. All right, I think we're going to get started here. Okay, so we'll go ahead and kick this off here. The reason you guys are here, we're going to talk about Salesforce IoT. We're going to be doing building, we're going to be debugging, and we're going to talk lifecycle management, ALM. And in the course of doing that, you're going to hear from myself. My name is George Sains. I am on the product team for IoT. I've been at Salesforce for 2 years, focused exclusively on this product. And we got Justin up here, and Justin's one of my coworkers. He and I work pretty closely together on Salesforce IoT. So we're going to be walking you through what Salesforce IoT is, how you can build it, how you can debug it, and how you can manage it. Of course, no DX presentation would be complete without this slide. Please make purchasing decisions based on currently available features, and we're done. What are we going to do with the next 40 minutes? We're going to talk about a business use case, because ultimately, at Salesforce IoT, we believe that IoT is there to not be a red item on your accounting sheet every year. It's about deriving more value from connected products. So that's profit. So we're going to talk a little bit about why we might build an IoT use case. We're going to talk about what Salesforce IoT is, what the constituent parts are, what the technologies that underpin them are, and how they work. Then we're going to spend the majority of time watching me totally biff it in a live build. I'm pretty sure that I won't make too many mistakes.
Do you have your fingers warmed up?
I got my fingers ready for this.
All right.
We're going to do 20 minutes there. We're going to go through soup to nuts. We're going to build everything out. I've got a little electric imp up here, which is sending live data. And we're going to actually build an orchestration to react to it.
Cool.
And then finally, we're going to have a question and answers period at the end. So let's talk a little bit about why we might build a particular IoT use case. And we're going to talk about a customer that, if anyone has been in IoT sessions over, for Dreamforce or last year at TDX, you may have seen us talking about Emerson, because we've been a customer of ours for about 2 years. And we started with this really cool use case in the residential heating and cooling climate technologies group. However, we've been so successful there at Emerson that we've actually moved on, and we've basically built a new use case in their cargo division. So what are these two things that I'm showing you? Obviously, we've got a raspberry up there.
A berry?
A berry, yes. And you guys narrowly avoided it. I was going to make like some Raspberry Pi joke in the title, but I'm not one for puns. So we've got the raspberry over there. What are we doing with it? So Emerson Cargo is in the business of providing cooling, basically a cooling experience for groceries. So when a particular grower wants to ship their product to a grocer, they insure it and they send it on an 18-wheeler that has an Emerson HVAC unit attached to it. And that Emerson HVAC unit is sold to the customer as providing a certain temperature for the produce. In this case, we're going to talk about raspberries. Fun fact, depending on the time of year and the grower, a tractor trailer full of raspberries is worth anywhere between $300,000 and $500,000. Wow. So, yeah, it's quite a bit of money. And as you might imagine, if you're the grower or the grocer who is paid for this, you want to make sure that those raspberries don't get to you at 104 degrees in an Arizona July, in the middle of the summer. So what they do is they attach these things over here on the left. These are Locust Trax temperature monitors to each shipment. They put it in right on the cargo containers full of raspberries. And over the course of the shipment, they monitor the temperature in real time, and they have the equivalent of an SLA. So they say the temperature needs to be between this degree and this degree for the majority of the transit. And if it's not, they can call the person actually driving the truck. They can call the grocer or the distro center on the other side, let them know, hey, that truck has been out of range for about 3.5 hours. Those berries are no good. You got to reorder. They can even ask the trucker to open up the back, break the seal on the raspberries, and take a photo so that they can have basically an insurance claim against the raspberries.
So they're driving a much better customer experience.
They're driving the customer experience where previously they would just ship the raspberries, and sometimes they'd come out the other end less than edible. Now they can monitor it en route to ensure that when they get there, they can actually sell them.
Cool.
So what we're going to do is this device actually has a few sensors on it. The one we're going to be talking about or going to be using today is the temperature sensor, and we're going to simulate a use case where we monitor temperature and become proactively engaged with the service team. So with that, that's what we're doing. I kind of skipped slides here. Why don't we just go ahead and talk about what Salesforce IoT is? And for that, I'll turn it over to you, Justin.
Cool. And we'll just touch on this very quickly, and then we'll get into the interesting stuff, which is actually building the soup to nuts. But we want to define what Salesforce IoT is and isn't. So when we talk about Salesforce IoT, we really look at the whole entire ecosystem. And that starts with what we kind of term the infrastructure. So we start with the things themselves, a locust track, a thermostat, a robot sitting in a factory floor, an app on a phone, whatever it is, that's actually generating data. Now it's connected to the internet or a gateway. And then we have some way to actually connect all of that together so we can get the data somewhere, likely into an IoT platform. This could be a public cloud. It could be something you guys might have built yourself in your own data center. But ultimately, that cloud or that platform is providing device management. It's providing a way to actually aggregate all the data together. And then ultimately, what we're trying to bring to the table when we talk about Salesforce IoT today is how you can transform all that device data with some notion of a context, which I'll get into, and actually transform that into the customer experience. What George was talking about, being able to call that delivery driver, right, or being able to open the back of that container to take some action in real time or at the right time. And we'll kind of go through that today, and we use Salesforce IoT to kind of bridge that gap between the infrastructure in the IoT ecosystem and actually making use of it within your CRM system. And so we have a couple of parts in order to do that, because now, as of last Dreamforce, we are a part of the Salesforce platform. So that means we get to take advantage of a lot of the things that it provides. In this case, we can use platform events. Anyone use platform events here? Okay, a few.
Good.
So essentially that allows you to define a shape of data as an event directly in the Salesforce platform, and you can use that to trigger different things, whether it's within Salesforce IoT to actually process that event that might be coming in from an external IoT device, or even take action based on a particular process you want to run directly inside of the Salesforce platform. So once you actually have the data shaped and into Salesforce IoT, there's two key things that we provide through the platform that allow you to take advantage of that. The first is the context, and the context is really going to allow you to marry up that device data that's coming in this case from our sensors on the electric imp device, with context you might have. So anything you know about your customer sitting in your Salesforce org, when was that thing installed? Is the customer high value or not? Anything you want to use to make decisions can be married up with that event data and then acted on in an orchestration. And as we'll see in a little while, that's really where you define your business rules in an Excel-like interface that allows you to make decisions and take action so you can really translate all that device data into action or experience you want to drive to your customers. All right. Are we ready to build?
We could build, yeah, we can just skip this one.
Let's go through
Let's
this.
go to the build.
Okay, so we need a couple things here, right? Well, obviously we have the device, but the device needs to actually be sending us data. And we need a couple things to do that. So what we have here is we're using an electric imp, right? It has a number of sensors on it. Mainly we're making sense of temperature. We're looking at temperature readings in the room right now. So there's code on the right-hand side that's actually running on the device to grab all those temperatures at a particular frequency and then send it up to the imp cloud. The imp cloud, think of that as our IoT platform. All that's going to be doing is using a connected app, which we'll set up in a minute inside of your Salesforce org, as a way to get OAuth settings, which you can see here highlighted in the lower left, as a way to send that event data into your Salesforce org. And it's going to be shaped as a platform event. And when those platform events hit the org, we're going to be able to actually react to them, which we'll see as we build this out. So now that we know that we have our data being sensed in the room and being sent in, let's go ahead into a Salesforce org and let's take a look at the connected app. And so while George pulls that up, we're just going to briefly talk about this. This is just a standard connected app that you guys would define that's going to provide the OAuth settings that you would put into the electric imp that allows you to make standard HTTP posts in the Salesforce API to create the platform event messages and send that over to the org. So again, we've taken those settings and we're actually creating a platform event. But unfortunately, we don't have a platform event yet in the org, so I think that's the next step of what we need to do. We have our data coming over, but we actually need to define the shape of it. And that's why we're seeing errors, because we're trying to send it, but there's nothing in the org to actually receive that data, so we're getting an error back in HTTP post. So George is going to go in here, and as I said, platform events are a standard part of the Salesforce platform that we and other parts of the platform, even you guys, can take advantage of once you define them. So we'll define one here. We're going to call it a container event because, remember, we're simulating this device being inside an 18-wheeler container taking temperature readings. And we're going to define a couple things. One, we need a device identifier, right? Because I could have multiple containers on the road in 18-wheel trucks that each have these different locus tracks, or in this case, our simulated electric imp in them. So we need a device ID, and it's going to be required. And the other thing that we need is we actually need the temperature, right? So we're going to define another custom field on the platform event, which is going to be a temperature reading, and that'll be of type number. And there's nothing fancy about it. That's just going to keep all the readings that are coming in from the electric imp able to be accessed through the messages that are being sent in as platform events. And the last thing we need is a timestamp. And you might say, well, whenever I create a standard record on a standard or a custom object, I get a create a date field. That's true. But with IoT, a lot of times you actually want to make decisions based on time information where it originated on the device itself. So that TS field is going to represent when the device, this electric imp, actually emitted the event. And so now we have enough information for us to get started. And if we go back over here and actually look in the lower panel, great. The demo gods are with us, George.
Whew. Don't jinx it.
First step is complete. So at this point, we've sent data successfully into the Salesforce org in the shape that we defined in that platform event. But we're not really doing anything with it right now, right? I think you want to do something with it, right?
Yep.
So let's go into the IoT objects that I mentioned inside of the standard org, and we're going to start with the context here. So we need to define a name for that context, because remember, we're trying to define the platform events we want to listen to, and then any reference data, our standard or custom objects we have in our org, and marry those two together so we can make decisions around that data in real time. So let's go ahead and we'll add in that container event that George just defined a minute ago. And you're selecting a key. What's the key, George?
So the way that we, in a moment here, you'll see those two columns again. And the way that we associate the event data generated by the locus tracks or any event, any device that you want to use with Salesforce data is we use a key. And we call this just a key field here, but you can think of it as a foreign key relationship. And you'll see that in just a moment when we go and associate it with an S object. It can be an S or a C object. But what we're doing right now is telling Salesforce, this is the field that we want to use when we do that lookup.
Gotcha. And that lookup will be occurring whenever a device event actually comes in that is associated with this particular context. So we'll go ahead and select the right field.
And I just want to point out here, this is really, really useful because you guys will probably have your S objects or your C objects configured in a certain way. And it's often the case that the IT group that's managing the devices and the group that's managing your service team will call the same field something different. You can have, in this case, I'm showing an example where the service team refers to it as locus ID because they know that that's the device field that they use to uniquely identify one of these temperature sensors. But the IT team that they're working with calls it device ID. That's not a problem for Salesforce IoT. You can name the keys whatever you'd like as long as they, at runtime, evaluate to the same value. So just wanted to call that out.
That's a good point. So once we actually have that, you can see that we now have created a context that has platform event we care about on the left and the context object on the right, the reference data. So we now have been able to associate all this data together, but we're not making any decisions on it, right? We're not doing anything with it. So let's create an orchestration. And again, that's going to be like the Excel-like interface, which is going to allow us to create business logic around that event or that context data, that reference data that we've associated together. We'll pick our context, and then that's going to drop us into this wizard here. And that's going to allow us to define different states that we know that our device can be in, right? In this case, we could have a monitoring state, right? This thing is just sending up readings, but we're not doing anything with it. But what if those readings change and it gets a little too warm, right? If those raspberries are about to spoil. We want to actually represent that as a virtual state here, or a virtual state for our device, so that we can take different decisions or actions if we get into those states. Because underlying an orchestration is a state machine. And that really is a key concept that we'll be coming back to. So I think we have enough at this point that we should be able to act on this data, but this is DX, George, right? So we've kind of used the UI, but that's not really fun, is it?
No, we got to go and do some UI, some API stuff.
Okay.
So
do we have an API?
We do. So this is actually a great point to make. As of 2.12, Salesforce IoT has a full REST API. So for folks who are interested in making use of that, please go ahead. It's publicly documented. Search for Salesforce IoT API. There's a quick start guide. We'll show a slide at the end with the exact name of it. I'd highly recommend folks to get involved and try it out. Things that we've seen our customers use it for testing. So you might want to call certain routes to invoke, create and delete objects en masse. You may want to go ahead and actually build. You could, for instance, build a Visualforce page that automates the creation of the records that we just showed. Obviously, APIs are intended to give, as a tool set for you guys to figure out what it is you want to do next. So this is just the beginning.
Great. And we don't have to use, Workbench. You can use any RESTful client that you want, right? And so we're just using here for simplicity's sake. So George is logged in. We're going to do a couple of operations. The first is we're actually going to create a context. So the payload is just JSON, and we'll talk about a couple of key fields. But really what we're doing is we're just doing a standard HTTP post over to the API to create the context.
Yep. So just calling out a few things here. You notice that we have to call the API name of the associated platform event. So remember the thing that we were looking at a few minutes ago with the 2 columns and the circle in the middle. We're going to create that object here using this JSON blob. And we do need to name the container event. We also need to name the key on the S object we want to associate with it. And we're going to give this thing a label. So in just a moment after we post this, we'll go back to the UI just to make sure it got created. And we should be looking for a context called API context.
Cool.
Because super original.
Let's do it. Oh, success. So the demo gods are continuing to be with us. All right. So if we refresh here, we should actually see the other context. Great.
Yep.
So we can do the same thing with orchestration. Now, the JSON blob is a little bit more complex, but it's still very easy to get started. Once George pastes in here, we'll actually walk through a couple of key fields that you should think about if you were to actually submit a request in our API to create orchestration.
Yeah, so you've got a bunch of fields, and I won't walk you through all of them, but suffice it to say that if you're familiar with the way that an orchestration works, and by familiar I mean like you've built 1 or 2 of them, this will start looking really, really simple to you. The way in which that I see this is I'm looking here and I say, well, we've got a definition, and we have states, because an orchestration is a finite state machine. It's got states, rules, and within those rules, you can do actions. So what we're looking at here is actually an orchestration that goes and creates a case when certain conditions are met. And when we create that case, we're going to assign the case, we're going to do some field mappings. So were we to instantiate, create this record, and then run the orchestration in a certain way that met the conditions, we'd create a case with the subject API case creation. And down here at the bottom, just as we did with the context, I'm going to call this API orchestration. So that when we post it, we can go and check out the resulting record over in the UI.
So let's refresh orchestrations again, and boom. So that's great. That's a nice little detour, but I don't think we need to do much more than that, right? So let's go ahead and delete that stuff. Let's clean it up so we can get back to our good state, and then we'll finish building out the orchestration.
Exactly.
So George is going to submit a delete request, and the key thing that we need here, we actually need the record ID. So that's what you're grabbing from the UI, right?
In the same way that you guys might be familiar with grabbing record IDs out of the rest of Salesforce, the same is true for IoT objects. So you'll notice all I do is navigate to the record view. In this case, it looks like this for a context. And I'm just grabbing the record ID and passing that over via Workbench.
To the right route. So we'll change that to context, put the right ID, and boom, we should be done. Cool. So now we've been able to show you how you can do a create, a get, as well as a delete. So let's go back to our orchestration. I think we need to do a little bit more building.
Yeah, this isn't doing much.
So we actually want to make sure when those berries have a spike in temperature for whatever reason that they're not going to expire, right? So what do we need to do?
Well, the first thing we need to do, actually, is as a North American, well, just as an American, I do all of my temperatures in Fahrenheit. And this is actually passing me temperatures in Celsius. So earlier today, I came in here and realized that it was a little chilly 24 degrees. But realistically, you might want to do these transforms. And one of the ways you can do that is to set up a variable. So what I'm going to do here is I'm going to create a variable that just does a simple convert from Celsius to Fahrenheit. And then I'm going to create a second variable because orchestrations are capable of generating data that you could then report or build dashboards upon. And as a business owner, I might be really interested to know not just what the current temperature of my device is, but how much, basically the ratio of the current temperature to the max temperature. Because maybe I want to build a dashboard elsewhere in Salesforce to rate how well the carriers do against their SLAs.
Correct.
So I'm going to go and create these variables with a little copy-paste here.
And it's key to understand that when an event actually reaches a context and gets passed into an orchestration that it's associated with, these variables in this case are actually going to get updated because we're creating the variables or updating their values based on events coming in, which is why George is selecting the event type, that container event that we created initially. And we're going to use a custom formula. In this case, we're going to convert from Celsius to Fahrenheit, and we'll have an initial value of 0. So the first time an event comes in, it'll have 0, and then we'll do an update. Additionally, we'll do the similar thing for the temperature ratio, and we're going to use another formula that'll go ahead and look at the ratio of the existing temperature on the event that's coming in from the device at that moment, and then the max temperature for the container. And so once we have that, we can use those in rules to actually create business logic, right?
Mm-hmm. And I want to call out one thing right here, because the syntax for referencing data in Salesforce is incredibly simple.
Good point.
So what we're doing actually here is I'm saying, look at the asset object and give me the max temperature field on that object. And that's all that's required at runtime for me to go and do a lookup against that. And we'll probably be able to show you that in just a little bit.
And this would essentially be populated through autocomplete with any reference data object you've defined on your context. So right now we've used an asset, but a lot of customers use custom records or custom objects, or they use accounts or other things. So just keep that in mind. So what have you actually just pasted in here very fast, George?
So what I'm doing is we're going to create, obviously this is quite a bit more simple than the Emerson Carter group is doing, but for the purposes of a quick demo here, I'm just saying, well, I want the temperature to be exceeded at least twice before we go and do anything that involves the service team, because the service team's time is costly, and I want to make sure it's out of range for a period of time before they get involved. So what we're doing is we're saying in the monitoring state, wait until the converted temperature is outside of the range that the service team has told me is acceptable for this particular shipment and unit, and then wait until that happens once more, and then we're going to go and create a case, which is what this is going to do.
So essentially, the first time an event comes in from that particular device, will get dropped into the monitoring state. We'll try to evaluate the rule. And if the temperature is above that, we will transition to the warm temp state. And the next time an event comes in, right, because this is continuing to send events in this scenario, we will evaluate the rule again, and if it is still above that temp, we will then transition in order to create a case. Because ultimately, we want to create an action, because a lot of times that's how we're going to connect that experience to the customer, right?
Exactly.
So we're going to create a case here. Now, you don't have access to only cases. You have access to any standard custom object in your org, but we're going to keep it simple right now. So we're going to create a case. We're not going to do other CRUD ops right now. And we're going to just populate a couple fields, right?
Yeah, so what we're doing here is we're writing, again, we're accessing that asset record, and we're also basically writing out the current device at the temperature, so that when the service agent opens up that case, they don't have to go and call the trucker and be like, hey, can you read the device? I think it's got numbers on it. Can you read it? What's the device serial number or whatever? You can just do a join against that. The case will say it's at 84 degrees. It was right outside, Phoenix. It's been operating for 13 hours. This is the current speed, whatever. All of that data can be mapped in here. Now, we're not going to go do all the output fields, but this is just an example.
So if I'm the service agent that gets that case, I should hopefully be able to resolve it much quicker because I have that real-time information already available to me.
Exactly.
I see.
Yep.
Okay.
All right.
So we'll name it. And what are you doing here? You're creating some type of response event?
Yeah. So when we go and create the case, with all distributed systems, you want to trust but verify. So what we're doing here is when we go out to Salesforce and say, hey, please create that case record, we don't want to necessarily take the next action until Salesforce comes back to us and says, yep, the Oracle record is written, the row in the database is good, you can move forward. And what we're going to do is we're going to use this, what we call a response event, to take action, to gate upon the successful record create so that we know that we can take the next action safely.
Got it. So we'll go ahead and type in a name here so it's visible to us, and then we're going to go ahead and add one more.
Yep, doing exactly what we just said. So I'm going to say when the case response is success field is equal to true, we're going to go ahead.
Transition back, right?
Yeah, this is incorrect. I'm going to do nothing here and transition back to monitoring.
Perfect. So we should have something that theoretically will work, right?
Well, you'd think so. Again, we've been lucky
so.
so far, so let's plan on that.
Okay.
All right,
Well-
so it's saved successfully. Yeah.
Do you want to look at the states view really quick? Because this is a good,
a good
handy
idea.
view to kind of develop. But this gives you like kind of the visual understanding a little bit of what's going on with the orchestration you built.
Yep.
All right.
This looks pretty good.
Yeah, I think so. I hope so.
We're going to activate this, and what we're doing when we activate this is making it, basically, we're bringing it from basically in dev to a production orchestration. And were this to work correctly, we see one of these bubbles move. And we could wait here for a moment, maybe two, while we see whether or not it's going to come in. If it does come in, one of these bubbles is going to get really big, and we're going to move. But I think we might have a problem.
I hope not.
I hope not too, but we did call this a debugging session.
That's true. That's
So, it's been a while. We've been sitting here. Nothing seems to be moving. So now, why don't we try and check out some of the debugging tools that we've got available to us?
Okay.
So,
Where do we start?
well, let's go back and check out the usage. So at any given time, we've been sending data to this org for a little while, this little device. So what we should be able to see is that events are received. And in 2.12, we launched a new feature here, which permits us to see, well, heck, yeah, we received 83 events.
Perfect.
Well, what's going on? Well, we've even processed an event.
But it didn't create any instances, right?
Yeah, this is not good. So we're going to go back to our orchestration. I'm going to check this out. Oh,
Well, it did create an instance, but it's in the error state.
yeah, so we created an error. So what this error down here means that at runtime, something unexpected occurred. And it occurred in a way that I hadn't actually handled. So, you might think, you guys just watched me build all that. Do you see what did I do wrong? Any ideas? Anyone?
Anyone?
I thought I did it. I think I did it pretty much correct. But luckily, we have another feature, and I'm going to show you something that's forward-looking. This is like a summer 2018
It's
feature.
kind of like a feature preview.
It's a feature preview, because this is actually a current production org, but I'm going to access this feature and
It's
show
not
you
the
what.
prettiest, but it should give you guys a general idea.
Yeah. So what we're seeing here is that we've got a problem, and I don't know if you guys can read that, but it's saying we've got a division by zero issue,
Ooh.
specifically related to
Oh, didn't you
max temp.
Didn't
something
you
with
set the
max
temp on the record?
I think the only place I reference max temp is over here, actually. Okay, all right. So if we take a look back at our record, sure enough,
Oops.
we've got a data quality issue. So yes, we had a divide by zero error because either the service rep filled out an incorrect maximum temperature on our asset record, or they just never entered it because it wasn't made a required field. But we can go ahead and fix this.
Yeah, let's update that.
Yep, exactly. So we're going to make this 80 degrees because I think I'm fairly warm-blooded. I think I'll be able to boost it. And when we come back over here, I'm going to reactivate and clear this instance because there are ways that we could avoid it ever going to the instance state, but I wanted to illustrate that for
And just to
purposes of
clarify,
the demo.
we create an instance when we get an event that has a particular identifier, and we've seen that for the first time. So if you think about, right now we only have one of these devices simulating a tracker in a container, right? But if we had 5 containers out on their own, each with their own device, they're all going to have different IDs. So we would then, in that case, have 5 instances potentially, right?
Yep.
Okay.
So we see what I was just mentioning a moment ago. Circles are growing. It means that we've actually received an event. But we can see that this particular shipment is operating at temp. Things are just fine. And what we're going to do is we're actually going to create a $400,000 problem right here by putting my finger on the temperature reading. And if I'm sufficiently warm enough, what we'll do is we'll go from the monitoring state over to the warm temperature state. Because as I'm holding my finger on top of this diode, the temperature readings are going to be going up. And this sends, I think, once every 10 seconds or so.
And if that works, we should check that logic that we put in there, and theoretically then, if it's warm enough, it should create a case.
Yep. And we can actually check over here on the imp to see what our current temperature is.
The readings are sending.
Yep. Yeah, let me go all the way down here. And we're at
25.
Man, I'm not warm.
I don't think you're warm enough.
I might not be warm enough.
We might have our first failure.
We might actually have to change the threshold
You
there.
should blow some hot air on it. No?
Well, what I'm going to do is I'm actually going to change the threshold here so that we can.
A little bit lower, right?
Yeah, so that we can
And
perhaps.
because those events are getting married with that reference records in real time, if we make changes, the next event that comes in will be married up with that record that has the changed information on it, right? There's nothing to stop us then from hopefully reacting to that lower max temp
Yeah.
in a moment here.
Here we go. All right. So what I just did was I just changed the asset record, and I mentioned that this happens, the actual joins and the lookups happen in real time. So I'm holding my finger on top of this. I've exceeded the temperature. We've transitioned to the warm temp state, which means that the next time we send an event off of this device, we'll go over to create a case, and then this is going to wait for the Salesforce response, and we're going to have created a record.
So we should be able to go look at that case, and we should be able to see the real-time temperature data in the case itself. Again, because we want to reduce the time it takes to resolve these cases for the service agent.
Look at that. Woo.
78 degrees.
It's a good thing I changed that.
It is.
I'm not sure I would have been able to push that over 80. So with that, that kind of concludes the actual demo building portion. I'm going to show you a little bit about what we're doing, a sneak peek into features that are coming up.
Ooh, these are coming in summer 18, right?
These are summer 18 features.
Okay.
So a moment ago, I showed you kind of a pre-release version of what I'm showing up here, which is the activity log. So when things get logged in the product, if there's an error that occurs, you can access them here, you can export, you can filter, you can sort. You'll be capable of seeing the raw event data and understanding what went wrong. We've also got this feature called the tracker, which you can see over here on the right pane, which does sort of the inverse, whereas the activity log is doing runtime logging. This is actually recording what the orchestration does, the things that might not have otherwise gotten logged, like variable assignments, state transitions. The purpose of using the two in tandem, of course, is that you build your thing, you have your tracker up, you can see, oh, it actually transitioned state correctly, the variables were set, and you keep the activity log around so that if you make a divide by zero error, which is strictly impossible, I'm sure none of you would ever do that, then you can actually catch it. You come back the next time you use the product and you see, oh, actually, I've made an assumption that perhaps wasn't correct.
Oh, so this is more real time. You're actually looking at this as the event data is coming in and reaching that particular orchestration.
Yep.
Got it.
So we'll open up. We ran a little bit over. We got about 8 minutes. We can ask questions in. So yeah.
And if you guys do have questions, we'd love for you to use the mics because we're recording this session.
Yeah. Folks are going to presumably, I don't know, are we going to get rewatched again?
How long does the instance stay up? How long does the session last? And if you get thousands of events coming in, does it create multiple instances? And how do you load balance it, or how many number of instances you create?
Sure. So the instances are created by key. So you only ever get one instance for one key. Those keys that we had set up in the context.
Correct.
So for instance, if you had 1,000 of these, you'd have 1,000 instances. To your second question about how we load balance, we have ordering guarantees. You can send to multiple platform events. They get ordered into a queue. We consume from the queue. And so were you to send data from 1,000 devices across several PEs, they'd all get ordered and consumed, basically one at a time off the bottom of that list, or the queue rather. Does that answer your question?
How long does the instance stay alive?
Sure.
Oh, okay. So the question is, how long does the instance stay alive? That's a very good question. So I'll give you the simple answer, and then there's a slightly more nuanced version. So instances will persist as long as you don't do anything about them. So if I hadn't activated and cleared the instances on that orchestration a moment ago, that instance would remain as a record in a table in Salesforce. They have a trivial impact on your data storage. They're relatively small, but they will persist. Now, you can get rid of them, of course, and the caveat to that is that we have an allocation for the number of devices or instances that the system can manage, but you can sort of cheat that limit by exiting. So you probably didn't see it, but in the transition rules, you can say, after certain conditions are met, exit the orchestration. What that does is it zeroes the row, it removes the instance. So you can, for instance, write a short-lived orchestration if you'd like. That handles a lot more than the allocations actually support.
And we have customers doing both. So again, it depends on what the use case is, but it'll support both.
Yeah.
Any other questions?
So what other things that you can do except temperature? What else?
What can your devices do? I mean, it really it depends on what the sensors are on a particular device and what they can send in, right? It could be information from a telematics device on a car. It could be information from this device sitting in a container.
So
It depends. It doesn't really
depends
matter.
on the hardware.
Yes, it depends on what's collected by the firmware. It really depends on, from the customer standpoint, what you might have already constructed as part of your connected product, right? We could be collecting information on chlorine levels from a hot tub. It really depends, and as long as you're defining the right shape within the platform event, it doesn't really matter.
So if I have a 5 million machine and they are located in different area,
Mm-hmm.
can it do location?
Mhm.
Can it, if the machine have problem, can verify where the problem and
Yeah.
at which customer, at which location?
Yep. We usually see that in a couple of cases, right? I just went on site with one customer where they wanted to really do a vehicle location within range of a particular account they have, which is a service center, right, where they might fix the vehicle. So they were doing geolocation queries in Apex as device data was being sent in. And in terms of, you have 5 million devices all over the case, there could be such that only the events are sending in a very little amount of data, and the majority of that data might live in the context object that you're referencing. Maybe the asset tells where it was installed or last serviced, or you know how many cases are against it. And that's why it's so powerful for the context to really join together that event data, which might only have a few fields on it, and more knowledge that you have about your customer or your product sitting inside the Salesforce org. Now, most of the time, what we've seen from customers, especially with Explore, is all of that data will come into an IoT platform, and you might only send some of it over to us, or all of it, but it really depends, and the shape that you define in the platform event is what governs that.
Thank you.
Cool.
One cool use case I like to talk about is connected trash cans and connected sewer pipes. It's impressive.
So the orchestration that you showed, it was a pretty simple example of it, right? But
Yeah.
then how complicated can it go? Can it call something like in the back end, like can it call Apex, or to what level is it currently doing, or what's the plan for the future?
Sure.
There's a lot of complexity. I'd say that the biggest one, I'm so disappointed. Mark didn't show up to my session. So I co-presented with Mark Baer from Emerson at Dreamforce, and he totally ditched my session, talking about his Raspberries. But he actually built an orchestration. I think there were about 38 states, 150 some rules. They get very, very complex. In terms of their actual, which portions of the platform do they integrate with? We have a lot of plans to do additional work, but right now, basically anything that you do in platform, you can do with this. So.
Any particular reason that we didn't use the process builder or flow for this, or
Sure.
why different UI altogether?
Yeah.
That
Good
is a
question.
great question. All right, so Process Builder and Flow are pretty good. I've actually seen customers do some really impressive stuff with those tools. There are a few reasons why you might want to use IoT. First, scale. So at the moment, we can react to, 500,000 is the Explorer limit. It goes up to 1 million. Those aren't super large numbers, but we're going to have some announcements shortly that will add a lot of zeros to them. So there isn't really an upgrade path. For instance, if you wanted to react to 956 million events a day with Process Builder, it's just not something that the system can do, which IoT will be capable of doing. There's also a more nuanced answer, which is that if you try and build a lot of linear flows with Process Builder and then try and manage those flows, you'll know that it's comparatively difficult. Like I've been in orgs, very mature orgs that have 40 different process builders, and I try and create a case, and I'm like, what the heck, it doesn't work, I don't understand. And they're like, oh, well, there are 9 process builder tasks watching that. I'm like, where can I see that? And the answer is, well, you have to click into each one and open them all in 9 windows, and then you have to look at it gets very complex. Whereas the orchestration builder is actually quite a bit easier to use. And I can go on a little bit further, but I think those are the 2 predominant ones. It's a very good question. Sorry, what was that?
Debugging.
That's actually another, thank you for mentioning that. That's actually another reason why you use IoT, which is, actually, I think our debugging tools are actually better. So, especially with the release of activity log, especially with Tracker, like if you've, I'm sure that you set up trace flags on platform and gone and, sifted through hundreds and hundreds of lines to try and find your process builder task and what it's doing. The debugging tools are a little bit more sophisticated, and they're going to get a lot better in the next 2 releases. And in terms of actually debugging the interaction between the IoT product and process builder, realistically, it's a lot easier to track it over an IoT at this point. And I'm not sure. Did I answer your question, though? Yeah. Okay.
With the process builder, it doesn't use a queue to sequentially give the events in the order they came in.
Correct. So process builder, like especially if you're consuming for multiple PEs, there's no ordering guarantee.
Yep.
Whereas we do have ordering guarantees across PEs.
Correct.
That's platform events. So.
All right, I think we're at time.
I think
right?
they're gonna yank us off here. Thank you very much for coming.
Yeah,
Really
appreciate
appreciate
it.